Welcome to the final video of our integration video series. This is video 8, and we're looking at volumes of revolution about the y-axis in this one. Very similar to the last one, but let's have a look. Here's a key example here. Find the volume of the solid formed when the curve y equals x squared minus 1 is rotated about the y-axis this time between y equals minus 1 and y equals 3. So here's our y equals x squared minus 1 parabola in the green there. And it's going to be rotated between y equals minus 1 and y equals 3. Now y equals minus 1 is right down the bottom here, but y equals 3 is here. So we've got kind of like a line here. And that whole chunk at the bottom below that blue line is getting rotated around the y-axis. And so it's the volume formed by this whole section in here, a bit like I guess it's like a wine goblet or something like that. But this volume here, 3D, can you imagine a 3D rotation of the parabola? A bit hard to pick in your mind, but still. Okay, we have a formula that we can use. And so let's have a look. The volume equals, for this one, are rotated around the y-axis this time. It's a little different to the one we saw in the previous example. It's still got pi in it. We're still going to integrate between two y values this time, b and a. And we have to get the expression in terms of x squared to use this formula, and it'll be dy this time. So let's take our y equals x squared minus 1 original parabola function and get x squared out the front. So it shouldn't be too hard to just isolate x squared there. If we added 1 to both sides, we will get y plus 1 equals x squared, or with x squared totally isolated out the left-hand side, we can get x squared is equal to y plus 1. So it's that y plus 1 version that we're going to put into our formula. And we've got our y values of minus 1 and 3, so we're just filling up the formula, really. Volume is pi out the front, integral between 3 and minus 1. And our expression for x squared, instead of x squared, we're going to put that bracket in, y plus 1, we'll pop it in brackets there, dy. So when we integrate y plus 1 here, we'll have volume equals pi, and we'll have that square bracket that occurs once you've integrated things. And the integral of y plus 1, we add 1 to the power and divide by the new power, we'll get y squared over 2. Plus 1 is a normal number like 1. Our integral of 1 will be the letter y. And we want to figure that out between 3 and minus 1. Okay, so we've integrated there. We've got pi still out the front. So we will sub 3 wherever there's a y. And we'll subtract from that minus 1 subbed in wherever there's a y. So we'll get volume equals pi out the front of, we'll keep things fairly separate there. We'll get 3 squared, which is 9 over 2, plus our 3, minus, and we'll be careful to put this in brackets, minus 1 squared will be 1 over 2, minus 1, and that'll all work out to be, final answer, volume will be 8 pi units cubed. So that's the volume created by that parabola being rotated around the y-axis. So this is the key to remember here. This formula gives us the volume of revolution around the y-axis. And this is the other bit that was pretty key. We want to get an expression for x squared, so that can go into our formula where the x squared was. And then we just it's just an integration job after that, subbing in our two y values in this case. Hope that helps, and all the best for your study for this chapter on integration. Thanks for listening.